Hello everyone, welcome to my channel. Today we solve some 10 network questions. These 10 questions will cover almost all the basic concepts related to the network basics. In this we'll use KCL, KVLs and dependent independent source related questions as well as few capacitor based questions. In all these 10 questions I will cover almost all basics. First question is finding the I in the circuit. Before that I will explain you two basic concepts and most important concept for the network theory is one is KCL. This is Kirchhoff's current law. This law says that at one particular node or junction the sum of the entering currents equal to sum of the leaving currents. It's like one is entering, one is entering, one is leaving, one is leaving. So this you take I1, this you take I2, this I3, this I4. So as per the KCL, it's like sum of the entering currents. You see the arrow which is entering to the node. This is also entering to the node. These I4 and I2 are leaving the node. So what KCL says is sum of the entering currents like I1 plus I3, sum of entry currents equal to sum of leaving currents I2 plus I4. This is the KCL. So wherever you require like currents entering and leaving, we can use this law. And one more is KVL. This is correspond to Kirchhoff's voltage law. This law says that when we have voltage sources are dropped across the resistors in any loop, the sum of the all voltages are equal to 0. It means V1 plus V2 plus V3 equal to 0. This we can write sum of V I from 1 to n equal to 0. So this I will explain how we will use in the networks. So let's come to our problem. Here he is asking what is I in the problem. So this is I. So if you want to find this I told you take this junction. So this current we should know. This current I will take as a some I1. So to know this one, we should know this current. This I will take as a I2. Okay, now to know this I2, this you know to I2, this current we should know. So from here we will start, because this and this at this particular node, you see this is leaving, this is entering. So I will take one leaving current. So sum of the leaving 1 plus this sum I3 equal to 2 amps. So I3 will be 1 amp. So 1 plus 1 is 1 amp leaving and 2 amps is entering. So sum of the entering leaving currents are equal to sum of the entering currents. So we got I3 is 1 amp. So I1 amp is coming like this, and this is entering, this is leaving. So 1 amp is entering and 3 amps leaving and I2 is leaving. So 1 plus 1 amp sum of the entering currents equal to sum of the leaving 3 plus I2. So we have I2 equal to how much? I2 equal to 1 minus 3 equal to minus 2 amps. So this I2 equal to minus 2 amps. So this is entering, again this is leaving at this particular node, and I1 I taken as a direction. This I1 you can take like this also, but once I consider I will follow the same direction. Now I2 entering, I1 leaving, 4 amps also leaving. So therefore here I will write 4 leaving plus I1 leaving equal to I2 entering. So 4, so I1 will be I2 minus 4 equal to I1. So I1 equal to I2 is minus 2 minus 4, it is minus 6 amps. So I1 equal to minus 6 amps. So finally we arrive at this point. I1 entering, 5 amps entering, all entering. So at this time I plus 5 plus I1 equal to 0. So I equal to I plus 5 plus minus 6 equal to 0. Correct? Entering yes. I1 equal to I equal to is this. So we have I equal to 6 minus 6 plus 5 equal to minus 1. It comes as 1 amps. So answer this question is 1 amps. This is 1 amp. This is the correct answer. So in the KCL you have to find the where the known currents are known, and after that you have to see the currents at the particular nodes and find the final what they ask. This is all about this first question. We'll move further. So the question is, in this circuit the value of the voltage source. So here we will use the KVL. See, KVL always, I will give one example. This is example problem. We have network like this. So I will take this is V1, V2, V3, and current in the circuit is I. This is R1. So to write the KVL, the loop I will consider like this. So whenever you are starting the KVL, you take any terminal, whether it is from positive terminal or negative terminal, you follow only one road. Now it is, I will take, this is entering at negative terminal. So I always see it is coming from negative to positive, means low to high. So I will getting the increment. So low to high means, like if you take, I have 5 rupees, from here I am going to 10 rupees. So you are going up, so I will take V1 is positive. Next it is coming like this. So again low to high. So again V1 positive. Again here I. So you see this is coming like this. So here what happening? It is coming from high to low. So I will take as a minus V3. So here this is current, this is resistor. So power or voltage drop across resistor, we will take always the reference current direction. So now it is again positive to negative, minus drop I times R1 equal to 0. This is KVL. This is all about basics, like from where it is entering you take, and see here low to high, or we can write in other way also. Other way what is that is, see I will take reference is like this direction. So for that one what we'll get, see again I will start from V1. So this yellow, same concept I will use. So V1, what you call, it depends upon the direction of the current, but I will take, my reference is always same. So high to low. So I will take minus V1. Again the current direction I assume like this. This will be positive. Now this will be negative. So again minus I times R1. Now again here it is. One I taken. This one is going. Again here it is. Again now I will get positive, means V3. Again positive to negative, minus V2 equal to 0. This is again KVL when I take current in other direction. So this is the basic concept of the KVL. So now we will see the question. So this V voltage source we have to find. This voltage source we have to find. So I will simply apply the some KVL like this. So now we have V2. Whenever we have positive or V1 is mentioned, you connect, simply you take like this, you connect some voltage. Here also you take, if it is minus V2 we should connect negative first, positive is grounded. This is for minus V1. If it is minus V2 we will connect negative first, ground to positive, but here it is positive, that's why I connected this. So this is V2, this is V1. So if I apply the KVL in this loop, in this loop. That's what I already marked. So I will write KVL in main loop, that is I will take like this. So negative to positive, V2 minus 2 volts. I don't write V, I will take 2 minus, because positive to negative, E minus 4, again it is coming like this, ground from here, this is ground to ground, loop to ground, you have to write the KVL always, and minus 4 minus V1 equal to 0. So to find the VE, we require V1, V2, V1, we require V1 and V2. So by applying this loop here, if you apply this loop, we'll get the V2. Now loop 1, I will take, this is loop 1, this is loop 2, final, this is loop 3. So this is our loop 3. So from loop 1, KVL 1, I will get, again I told like this you have to go. So V2 minus 2 plus 1 minus 0 equal to 0. So I got V2 equal to minus 2 plus 1 minus 1 minus 1 volt. So V2 I got. So now V1, again KVL loop 1, like this I will go. So now V1 minus, so here positive to negative, negative to positive, 4, again minus 5. So this 10 volts also we can connect like this. Again high to low decrement, so minus 10 equal to 0. So V1 equal to minus 15 plus 4 minus 11. If we go to this side, it will be 11 volts. So substitute these two in this equation, we will get, therefore V2 is 1 minus, from this 1 minus 2 minus E is equal to minus 4 minus 11 equal to 0. So if we go this side, we got 2 minus 15, 16, 17 minus 16 amps. So the correct, 16 volts. 15, 17 minus 1 minus 16, yes, this is a basic about KVL, how we can apply the in any circuit. We'll go for other question. Yeah, again it is based on the KVL, KCL, and one little concept here in the circuit shown below. The charge 600 coulomb is delivered to the 100 volt source in 1 minute. The value of V1 must be here. So here we'll apply the KVL. As I told, we'll apply the KVL like this. So I will assume, so current is going like this, so I will assume this positive, negative. So this I assume I. So if I apply KVL again, what will happen? From here I will see, again positive to negative, minus V1, positive to negative, minus 60, again positive, negative to positive, plus 100, so minus 20, I equal to 0. Yeah, but in this we have two unknowns but only one equation, so we have to use the what they given in the question. So what is telling, charge of 600 coulomb delivered to a 100 volt source in 1 minute. Yeah, so for that one, he is telling that 100 volt source delivered 600 coulombs charge in 1 minute. We know the current I equal to the rate of change of charge per unit time. So this is the basic current equation. The rate of change of charge per unit time is nothing but the current. So here we have charge is given and the value in 1 minute. Basically when you see the exact units of this is coulombs and this is seconds, so it is given in minutes. We'll convert to 60. So 0, this is 10 amps. But the thing is, this I took when I don't know the current direction. It is telling that 100 volt source in delivered the 100 volt source delivered 600 coulomb in 1 minute. So delivered means this charge is consumed, so it is entering at this terminal. So how to use other, this is I exact. So now I will apply the KVL. So no need to write this, only I wrote this is for you to understand what we take whatever we want the current. But as per this we came to know that we should know I for to solve this question. So I find the I. So now I will write the KVL. Therefore KVL now is 60 again positive V1. Now the current entering like this, I exact I am finding, so minus 20 times I exact already found, this is only I exact, this is 10 minus here again 100 equal to 0. So now V1 equal to 200 300. So minus 360 minus 240 will get 240 volts is the answer. Correct now. 200 minus 300 minus 60 240 minus this comes to plus. Yes, the answer is 240. Here only the concept is you should know the what you call basic formula of the current. Here if you see charge, you should not apply the formula like Q equal to CV. It will take you to take the problem in other direction. So the basic of I is the rate of charge, the rate of change of charge per unit time is nothing but the current. So this is in amps. Okay, well let us so for this question answer is 240 volts. We'll move for other question. Yeah, this is also one basic problem. So here we is finding R1. So R1 is nothing but this. We'll enlarge this and find here only. Yeah, you see the basic circuit here given that here across these terminals we have 70 volts. It is 70 volts. So this knows, we know this, and 70 volts. If you see this, it is like here we have some 70 volts. This is 100 volts. This is 60 ohms. So first to find R1 we should know the current in this. Yes, we should know the current in this. So we should know the current in this. We should know current what is coming here. This current take Ix, this will take as Iy. No, we will take Ix only because these open terminals, what current across these terminals is always 0 amps because this is open circuit. So whatever the Ix is going to this, Ix is coming here, it will go to this, it will close like this. So this is only Ix. So now 100 minus 70, 30 by 60. So if you take Ix here only, it's coming. Simplicity, I replaced full this R1 R2 with 70 volts source, open circuited source. So now we have Ix equal to 100 minus 70 divided by 60. It will come 1 by 2. This is 1 by 2 amps. So 0.5 amps is coming here. So what we got is this is coming 0.5 amps. So now you see this 0.5 amps only is coming here, so this is also 0.5 amps. So 0.5 amps times R1 and 20 volts. So this I will take 0.5 amps is going like this. Yeah, 0.5 amps is going like this also. Now if you see this current 0.5 amps and here it is 20 volts, 0.5 amps times, yeah, now I will write the KVL. So if I write KVL here, now we will write KVL. Now 100 minus, because current always I told like this, so 0.5 times 60, if it comes here, minus 0.5 times R1, already is 20 volts is present here. Just I am writing the KVL across this after finding the current. Minus 20 amps equal to 0. Now if we solve, is 30, 70, 50, 50.5, 0.5 R1 equal to 50, 50, 500. This now 100 ohms. Just I simplified the equation. It is coming around R1 equal to 100 ohms. This is our answer. Now it is, yeah, answer is C. This is basic KVL case, and we can solve in other methods also, but this is the easy way to find the R1. Yeah, we'll go for next problem. Yeah, this is also basics of that what you call KVL. See this, they're asking, yes, so this is like going in a reverse way. Now earlier they gave the source and asked to find the sum of the rest. Now they given everything here and ask us to find the source voltage. So it is simply, now you see these two here 20 volts, here we don't know, we don't know, so only for our key is this 20 volts, only for us key is 20 volts. Now we'll see how it is going to take. Now let us solve 20 volts here. These two are in parallel. These two are in parallel. Yeah. So 90 parallel with 180. What will get? This you assume is R. This is assume nahi. This is R is 180. This is R by 2. So R by 2 parallel will get 3 R by 3. This you can use as like a formula. Now R by, this is R, this is R by 2. Now we got R by 3 means 60 ohm. Yeah, this combination we can replace with 60 ohm resistor. Yes, this is 60 ohm. We got 60 ohm here. Yeah, 60 ohm here. Now if you see 60 ohm across 20 volts, 20 volts across 60 ohm resistor is this. So what is the current here? Again 60 by, sorry, here it is 20 by 60 means 1 by 3 amps. Yeah, so 1 by 3 amps is coming this way, this 1 by 3 amps here at, so in 60 ohm also is going 1 by 3 amps. So again it will be here 20 volts, here it is 20 volts, 20 volts. Now we can see, now this 20 plus this 20, across this we have 40 volts. Simply now these like two batteries are connected like this. this 20, we got this 20. If you see this A and this B, we have some 20 volts here, 15 volts here. What is the total voltage at VAB? Voltage from VA to B is 20 plus 15, it's equal to 30. So same thing I used here, this 20, this 20, combination is we got 40. So let me erase this. Yeah, we got 40 here. Now 40 volts here. So we should know voltage divider rule. What it says is we have some voltage here, voltage source Vs and two resistors like this. So this is R1, this R2. I will take current from this I. So again it will be positive negative across this one is B2, this is across, this is P1. So P2 is nothing but Vs times R2 divided by R1 plus R2. Yeah, so same way we will find the across this also. See, now same concept. Now we have Vs here, this R1 is given, R1 given as 180, this R2 we don't know, sorry, 40, R2 is equal to 40 ohms, and this voltage we given is 40 volts. So this we will use. Earlier we know Vs and finding V2. Now we are going ulta. So now it is 40. We don't know Vs. We know R2. R2 is 40. R1 plus R2, 180 plus this we got 220. So this 2 we cancel. So Vs equal to 220 volts. This is the answer for our 220. I think this is 220. My mistake, it is given 320. This is 220. Answer is 20 for this question. This is like basic how you know how you use the voltage divider rule and where to apply by using this formula. By using this question we came to know. It simply see where it is one key point will be there for every network. You have to catch the key point for that particular network. We'll move further question. Yeah. So now we are going to the other type of questions where they will give dependent, what you call dependent variable. This is dependent variable. We see this is dependent source. We should know the difference between dependent and independent source. See, if it is given like this or like this, these two are independent voltage source, independent current source. If you see any circuit, it's like this. These two are independent, these two are dependent sources. This is here directly we can see some voltage, some 3 volts, some 2 amps current like that here. But if you see here, they will give some 2V and there they will give some 2I. So some controlling parameter will be there for this question. I will take like this. Some for dependent sources problem, you should find first where is that control variable. So if you see this question, first I will solve this question. If you see this question, see they are asking certain power observed by the load RL. So what is the power observed by the load RL? What is the power observed by the load RL? What is the power observed formula? P nothing but V into I. we should know first voltage and current. If you see here, we don't know the current as well as the voltage, but if you see this current is coming to I to I1. We don't know directly what is the value of I1, what is the voltage across RL. So first we know I, then we can find the V. So 2I1, so 2I1 is coming. What I told, if you see the independent dependent sources, you should target always control variable I1. So I1 is this, so this is coming like this. So I1 is coming like this, 1 volt. If you see this directly, this 1 volt is appear across 1 ohm. So 1 volt divided by 1 ohm, how much? You have 1 amp. Yeah, directly you got I1 equal to 1 amps. So so this 2I1 is nothing but 2 times 1 amp. We have 2 amps. Easy na? So first you target I1, targeted I1, found the I, and substitute in the equation. Now P equal to V times I. Now see 2I1, 2 amps is going. What is the voltage drop across this P? 2 ohm. So V2 ohm is nothing but 2 ohm and 2I1. So we know 2 times, what is 2I1? 2 times I1 is 2 amps. We have 4 volts. So I is 2I1 equal to 2 amps. So power is nothing but power observed equal to 4 times 2, 8. Yeah. Now power observed by power observed RL equal to 8 volts. Why it is called power observed is, see, if you see this resistor, current entering at this terminal, which one? Here. This is very important concept. The current entering at this terminal, so that's why they called power observed. If in next question we'll see what is power observed, what is the meaning of power delivered, and if it's this direction is reverse, what is power, it is power observed or power delivered. That type of questions we'll see next. So for this problem the answer is 8 volts, 8 watts. Power is in watts, so this is 8 watts. So same type of problem, but here it is like looking wise is a big. So yeah, he is asking V naught. First target V naught. Where it is V naught? Here. If you want to find V naught, you should know the I in the circuit. Yes, you should know the I in the circuit. I in the circuit you should know, or directly if this V2 you know directly, this, see, this V naught is nothing but, I will write the here solution. If we know V naught is nothing but 5 times of V2, so we should know the V2. So if you see V2, again I told this is a dependent source, you target always V2. Yeah, V2 targeted. If you see V2, this current, so V2 is what here? V2 is nothing but the drop across 8 ohms resistor. 0.31 times 8 equal to 2.4 times V1 equal to V2. So again we should know the, again I told you target again V1. Yes, targeted V1. So what is V1? Yeah, we have current going like this across, going to the 5 ohms resistor. So V1 is this current 0.2 amps going through 5 ohms. So drop is V1. So 5 to the, this is 1 volt. So we got now this is 1 volt. Yeah, now substitute this here, what we'll get? So if we substitute this here, we got 2.5 times 1 equal to 2.4. Again V1 you substitute here, is equal to 5 times V2. V2 is 2.4 again, 2.5. How much? 5 to the 10. So it is 12. Is yes. This is answer. Yeah, answer is D. This is 12. You got it now. Like you go behind, you first see the question what they are asking, and one by one, whenever you see this dependent sources, you target the control variable. So here is v2, again it is v1, again here it is v1. So targeted, and finally we found the solution in only one step. No need to think much about the circuit. You go back up to source, we will get the answer as a follows. Yeah, for this question answer is follows. Mainly here my focus is, if you see the unknown here, no need to find out here. If you see unknown control variable, how you will get that, mainly focus is in that one. For this two questions, my main intention is that how will you find the unknown control variable. Yeah, we'll go to other question. This is also same. Yeah, as I told you earlier, I told you what is observable, what is observed, and is what is delivered. In this I will clear your all doubts. So now the dependent source in the figure is that, yeah, here is asking the dependent source in figure. This delivers, observes, delivering 80 watt, observe 80 watts, or deliver 40 watts, or observes 40 watt. So we should know the dependent source. Which is dependent source? This is not the dependent source, this is the dependent source, because the source which is depend upon the control variable, that is v1. Yeah, now target v1. Yeah, for this question we have advantage that v1 already found and v1 already known. So simply you replace v1 by 20 by 5. Here it is what 4. Yeah, this current source now. So we got 4 amps here. Yeah, 4 amps here. Is asking dependent source whether it is observing or delivering the power. See, if his source is like this, this current is going, we'll see whether voltage is, this Vx is coming like this, or Vx is coming, we will take this V1 like this. Of that, power is nothing but, I will take this is I. So power is Vx into I. This is what? Delivering. So this is V deliver. If Vy into I, we got voltage as like this, we are delivering the power. If it is coming like this, power is observed. So we'll see how it will come now. Now this 4 amps is going, 4 amps is up to here. Now 4 amps is coming here, this 20 volts. We should know the current or voltage in this 5 amps. So I can use one what you call node. I will apply node here. Simply whenever you don't know any current or voltages in the particular branch or network, you use simply nodal analysis. Is very easy to find. Now I will apply KV voltage node at that point. So now I will get V by 5 plus V minus 20 by 5. This current is entering, so that's why I put minus equal to 0. LCM is 5, so V plus V minus 20 equal to 20. So 2V equal to 40, V equal to 20. So yeah, now you see this V I got 20. So this only V here. This is 20 volts. Now which is this matching? This current is going like this, so it is matching with first one. Vx is power delivering. Yeah, power is delivering. So what is the formula of P delivering? Equal to that whatever I told, Vx times I. What is Vx? We got 20 volts into I, how much? 4 amps. So 80, V into A is what? P deliver is 80 volts. Yes. So for this question is for this question answer is 80 volts. Yeah, that's what. Now for example, if we get the V as we got V as what you call less, means we got V as minus 20. That time it is observing the power. So always concentrate on the terminals of voltage across this particular dependent source. So if for this question the answer is it delivers 80 watts. We'll further go to next question. Yeah, this is also one interesting question. These questions we'll see in next lecture. Yeah, thank you so much.